Hello, everybody. So continuing where we left off the other day, there was that assignment given in class on Tuesday that, well, the main topic this week is we're looking at SQL. Oh, I'll let her in here and then I'll say this. Okay, yeah, so as I was just saying, continuing from where we left off the other day, the main topic this week is SQL. But SQL is pretty straightforward. It's not a super confusing part, not nearly as confusing as normalization, which I've already said a couple times. That is one of the most important things we cover in this class, because if we don't get to third normal form, which is pretty confusing, we lose functionality from our database. And that example for the other day was kind of the most common situation software developers will hit when they're making a database to go with a particular application that's already been built. And it was not normalized, and there were some things that we were missing. Some things, it fell short on it a couple places. If I open up the SQL code from the other day, I can point at a big one there. Open. So there were a few things, but this one right here in particular, that was what I mentioned whenever we were talking about the normalization section specifically. We can't put that on our other foreign key because it would not work on our other foreign key the way that was set up. So it wasn't in see how we're supposed to get that normalized before today so that we can continue. I guess I can just leave that open to look at it. So we'll edit this file. I did send that out in an announcement. Hopefully you were following along the other day and have something very, very similar, if not exactly the same, that you can edit into a normalized form when we look at that. And then we'll move on with joins, which is one of our most powerful situations. And the SQL code is very straightforward. It was written by Americans, so even though it's not perfectly grammatically correct English, for us English speakers especially, it follows our language enough that it's usually straightforward, easy to follow. And normalization is a much more confusing, as you all noticed. That's why I wanted to talk more about that. Right? You may have noticed the other day we were doing mostly the data definition DDL sort of SQL. We haven't really done a whole lot of DML yet, the data manipulation. We were just defining stuff, making tables, inserting data into those tables. We did look at the select query, and in the lecture, there wasn't much more than saying select queries exist, and we look at it really, really quick because that's not confusing. We want to make sure the confusing parts get clarified. And I wanted to look at this in sort of some diagrams to help make sense of what's going on. I've also been waiting on ways to simplify the wording that we hear over and over again. Right, researching that stuff on normalization, there was a bunch of big confusing words in there and probably didn't make a lot of sense. Some people were seeing, some people cited things with math notation and put it in pure math notation, not where the reference material you found wasn't even in English sentences. It just gave you the math notation to put it in. So we speak English, there's lots of synonyms, there's ways to simplify it. I wanted to do a quick sort of picture to look at. So really what I need here is just this to look like a table. So I'm going to hit format as table on a couple buttons. I want to work so that we can pretend like we have some sort of database. Format that as a table. I'll make this one the flag. Or I just need a couple to point at. And maybe a couple more over here. Here. And I'm scattering these around so it doesn't look super symmetrical, something more like we would have in a, as it's stored, because that's what I wanted to talk about with these pictures. I don't think I've done a blue one yet, that'll work. And I can zoom way out because there's no actual data to read here. So that's sort of what our database tables look like. And in particular, the thing with normalization, it's how we access how we can adjust this table. Actually, let me move this to get a slightly more accurate representation. So that is how this would be sort of stored in memory. And you probably encountered some words that you may not have realized how they fit in. But a lot of times we talk about horizontal and vertical with our database tables. And this is where the horizontal and vertical show up. So, grab my little pen. What color do I have? Oh, not white. Drawing green. Is horizontal and vertical in this direction. And that's where first normal form comes in. We can't stretch horizontally. Or we really should not stretch horizontally. So we don't want to have any horizontal duplicates. That's where our diagram from the other day fell apart. We'll get to that in a second. But I probably should have done those in red. Okay. We can't stretch our table out, and I set this up how somewhat representative of how it would be in storage. Is if we try to stretch horizontally, we only have a little bit of room before we run into the next table. And then we don't have any more space to go horizontally. So that's the duplicate columns. But there's a similar thing when we try to put multiple values in one column. That's a horizontal thing. By the nature of this table, here's an arrow that should have been green. It is perfectly okay to stretch our data that way. We can add more and more and more records. That's the intent. That's the very intention. So that's the vertical direction. So with normalization, we want to adjust it so that anything we need, any additions happen vertically, not horizontally. So you'll hear those words a lot. Clear those drawings. And what we lose with zoom in here somewhere. The reason we need to do this is when we set our conditions, we're going to get putting conditions on the selection structure today. We can jump right to any cell in that table. So maybe our condition is based off this cell right here. Remember, with relational databases, we say explicitly what type of data we have every time. So we know how much space all of them need in hard drive, on the hard drive. So we know exactly where every single one is. And if this is the only thing we need to look at for our condition, then we can just jump right to this cell and check that condition and then grab that record that it's related to. We don't have to worry about anything else in the rest of the database. We just go in there and grab that one record. And again, we have a horizontal and vertical thing. When we can check that one spot, but we need the entire horizontal that goes with it. So if we do things horizontally, the compounding values in one column, or we try to add too many columns, we can't skip over columns. That's a good way to say it. We can skip rows, but we can't skip columns. And that equates to time. And it adds up to a lot of time, really, with a modern data set. And if we have if we're working with a database for some big company, have online sales, and we're worried about something, I don't know, maybe people from Idaho, then when we go look through it, we're wasting a lot of time looking at all of the sales receipts and all of the addresses and all of the Facebook profiles for people that don't live in Idaho, if that's the only one we're concerned with. So we want to look at our data first. And remember, unlike most of our software, everything for the database is happening in storage, not in RAM. So if we lose that functionality by not getting the third normal form, then we have to bring our entire data set into RAM, which is going to take longer than if we would have filtered it before bringing it in, and then process it through it, and everything we do is going to take longer. And our data sets get huge. We have huge data sets, right? That example I just mentioned, if we were only concerned with people in Idaho, it's not a very heavily populated state. I don't know how many people live in Idaho, 5 million people, and there's 8 billion people on Earth. So it is by far the massive part of the number would be things we didn't need. If we're only concerned with people who live in Idaho, we don't need the other 8 billion people on Earth. The 5 million people that live in Idaho don't even affect how we say the population of Earth if we take them out of there. So we want to filter the data in storage instead of on RAM because it adds time at every single place. So that's the functionality we lose if we don't get into normal form. And those are the directions we want to worry about. So think about the picture of the table, and it has to do with stuff being horizontal and vertical here. So first normal form says there's no duplicates horizontally. We can go to vertical records, that'll be fine. We'll see that in a picture. I have when we actually get to talking about that assignment that was due 1 minute before class today. Vertical is fine. We can add rows to a table all day long. We can add more records. So anything that's how we get rid of first normal form or into first normal form. If things are stretching horizontally, we have to readjust them so that they stretch vertically instead. The second normal form and third normal form, some nice ways to put that. I put it in the grade book on a few people's assignments last week, or from 2 weeks ago. I got a little bit behind on grading because I was in Indianapolis all week last week. But on that assignment, I put in a couple people's grade book. A nice way to phrase that second normal form is we don't need any two-step relationships. So your assignment from 2 weeks ago, you were doing that book stuff, right? The book, the publisher, the author. And the author is only related to the publisher through the book. So we have to go from author to book to publisher. So that would be a transitive relationship. It has to translate through the book in order to form that connection. So we do not want any of those in the same table. So basically that means the author has no business in the publisher table. If that makes sense. Which this is less technical terms. Remember when you get asked questions about it, you're going to be asking in technical terms. But that's the way to think of it. Second normal form is we don't have any multi-step paths to get from the data point we're looking at to the primary key. And the third normal form is a direct relationship to a direct functional dependency on that. So we need to be directly related. Everything in this table, I have a picture in my hand and a table pulled up on the screen. All of this stuff, we have to be able to say for certain that it's part of this. So a good way to put that in English is using your assignment from a couple weeks ago. Book stuff goes in the book table. Publisher stuff goes in the publisher table. And author stuff goes in the author table. And then only the primary keys move over to the other table. Then we connect, so a primary key from the publisher will show up in the author table, but otherwise we need to explicitly say this is something about the author. An ISBN is about the book, has nothing to do with the author. That'd be a multi-step thing, but the author wrote the book and then sent that off to a publisher. So the author has nothing to do with the publisher, excluding the self-publishing agreement. Let's skip that to keep it kind of simple. The author has nothing to do with the publisher, so the author's name has no business in the publisher table. That's what third normal form is. Hopefully that, do those phrases make a little bit more sense? Trying to put it in normal English. So for first normal form, everything needs to go vertically when we're looking at thinking about a picture of a table. When we actually look at the table in our data, we can go vertically, but do not go horizontally because we'll bump into other stuff. Second normal form is in order to say that something is related to the primary key, we can't have to go through something else first. So the book one's a good example. The author is only related to the publisher if we go through the book. Author wrote a book that got published, but there's no direct relationship between the author and publisher. And then third normal form is an extenuation of that. It's all one-step relationships, and we can definitively say, do they belong together? So using the author, book, and publisher thing, only publisher things go in the publisher table. Only book things go in the book table, and only author things go in the author table, and then we bring over that key afterwards to tie the tables together. And that's where the thing, however, relational database comes in handy. Let me draw a couple lines on here. So if I zoom out, oh, can't zoom out with that on. I don't know if the pen, so I can zoom out and see all this stuff. So move that back over here so you can see it all on the screen at once. We have some relationships between our tables, right? Like maybe this is our primary key, so that ties into over there, and our primary key from here comes over here somewhere. Let me be explicit because I did mark that on a few people's assignments. And we do not have to keep the same name. So whenever you do a diagram, you want to make sure you have to make it clear which fields are connected because the names do not have to match. And then maybe the primary key from this one, if this is our primary key, go ahead and write that on here too. It comes over and connects to this other table over here somewhere. So then we set up our condition, the stuff we're going to get to today with SQL, when we get to joins, we know this data point, we know the condition that we want. When we find it here, then we can just trace that all the way around. I should do a different color here. One more, there we go. Put it in blue. Our condition finds this data point. We can trace it through the relationships in that row. It actually goes both ways. We need that entire row. But we can skip all of the other rows. So we have to pull everything horizontally. That's what first normal form is about. We don't want any extra stuff because we cannot skip it. But if we get from there, I'm going to break the line. So we get that record, and then we can jump right up here, follow that relationship around, and then jump to this point where we do the same thing. We pull in this row, jump up to the primary key, follow our relationship around, and maybe then this is the row we actually wanted. So we need any horizontal we put in our database, we have to take that. But we can skip all of as much vertical as we want. That's what first normal form is about. No duplicates and no compounding as we go horizontal. Does that make more sense? Does that clarify it a little? Any questions on that? Okay, I better clear those pictures. Where's my clear button go? There it goes. So clear that. I'll close out of this. I need to save that. And let's look at that. Let's look at the one from the other day, see what went wrong with it. Hopefully that clarified it a little. Nobody's speaking up that they're still confused. I have to get the Zoom stuff out of the way. I don't know where a good out of the way spot is for today. So here's our original. Let's open that up. And this is a very common problem for software developers to get. And 5 out of 8 people in this class are software developers. This is why I chose this. So things are going well, right? Employees, all of this is things about employees, right? If we look at the primary key, an employee has a name, or a name belongs to an employee. An employee has a salary. A salary is paid to an employee. An employee has a skill set. A skill set are the things this employee can do. So we can build those sentences off there. And that's the second, third normal form. There's no extra steps along the way. For second form, there's no everything in the employee table belongs to the employee. So it belongs in the employee table. There's no external data. We don't have anything about teams in employee data. That's a different thing altogether. Teams are about teams, so they need to be in the other table. The big problem we hit was these arrays. Because arrays are compound values. I also wanted to put in there because the standard example we'll see, they always use things like names and addresses. And that's debatable whether that's a compound value or not. My name's not Chris, it's Chris Francis. There's 2 parts to my name. And even the 2 parts of my name aren't really unique. Last time I looked, there was over 900 Facebook profiles for Chris Francis, and the statistics are 1 out of 7 people on Earth have a Facebook profile, which means there's probably 7 times more than 900 Chris Francis around. There's several celebrities, so I end up way down the list. But the first name isn't my name, it's my first, middle, and last name go together. It's one thing. So that part's debatable, but that's the standard example. Arrays are definitely compound value, right? We have a comma separated list, so there's several values. And that's where we hit problems. That's where we hit one of the problems that if we're not in third normal form, we can't guarantee in this on delete and on update. We can't put that on the team one, because to get from, if we did an update to jobs and tried to go back to teams, we hit an array and we can't access the stuff in that array from storage. We have to bring that back to RAM and process it in RAM in a more traditional sense. I shouldn't say traditional, a more normal way. Right, we have to bring it over to RAM and use a Python script to process the individual ID out of it and do stuff there. We want to do it in storage before we get to RAM. So those are the problems. And that reminder about the assignment, I said there's 3. So hopefully that was a clue. as to what was needed to normalize it. There's 3 arrays. It was also shown to, several people mentioned JSON as a data type, and JSON is there for a reason, and that reason is not to be a data type. You might remember the other day when we wanted to put that JSON array into our SQL code. This one. It's just text. Text is our data type, and we just have to make sure there's enough room for we make our text field big enough that it'll hold our array. So JSON, it's kind of loose calling that a data type. It's actually for the, after we get our data, we put it in a JSON array to return it, because that's the way we need it once it gets to the RAM chip. We'll see that this afternoon for sure. See the proper way to use that JSON array. It's not intended to be a data type, but there was 3 arrays, and in that hint, I said there was 3 things on my bullet. When I made a bulleted list for fixing it, there were 3 things on there. So hopefully that hint made it through, because that was what I fixed, was each of those 3 arrays. Zoom out so that list shows up on there. So there's the bulleted list. I have it drawn as well, so you can look at the picture as well. So I took the skill set array, and that showed up in the employee table and the equipment table. I just made another table for skill sets, right? And the horizontal and vertical again. So putting it in one column gave us a horizontal stretch. So what I did is took that column and turned it vertically into a table. That's what we have as software developers. That's what we have to do when we bring the arrays from our program over to a well-structured database that we can get all the functionality out of. Is that array is not a horizontal list of comma separated values. That's what we need it to be as the program. So we take that and put that in its own table so that it switches to a vertical thing instead of horizontal. And that's really what all 3 of these problems were. If you look at that list, the skill sets, it was in 2 different tables. So I turned it into just one table and a bridge table, and then brought the IDs from brought employee ID and equipment ID in as a primary key. And then those sentences that I was saying earlier. One employee has many skills. One skill is held by many employees. So to confirm that we have the one-to-many relationship both ways. Same thing with the teams. I actually had to break that up a couple of different ways. They couldn't go to the same table, so to normalize that, the employees array went to a bridge table. I call it assignments. Who's assigned to what particular team, and then the team has to take on it. And the equipment went to one. It took me longer than it should have to come up with a name for it, but I eventually settled on usage. Like, how many times was that tool used? So I was thinking that would be the useful word, right? That's what the manager is going to ask whenever a tool breaks sooner than they expected it to. They're like, "Oh, thought we were going to get 5 years out of this lawnmower. What happened with the usage?" And then they can check the database and notice that that was everybody's favorite lawnmower, so it got used 10 times more than any of the other lawnmowers. So it got the usage they were expecting, but in half the time. So useful names go a long way too. Try to think about things like that. Like, if you're the database administrator, how is management and accounting going to ask for the data that you're administrating? What's going to be in the question? That makes queries a lot easier to put together. Zoom back out, and it just kind of looks like this. So I just threw this extra table in the middle, and you'll notice that there's no extra data put in that table. It's just foreign keys. That's what a bridge table, that's the idea for a bridge table. I knew that. I'll write her a message afterwards. I need to get on that quick. That was about the Java course redevelopment. I want to do that, but I hadn't applied yet because I'm going to be grabbing a Java certification because nobody teaches the Java certification course, and Ivy Online really needs to run that. I was like, well, I know I like that course. So I told her why I hadn't applied to redevelop the Java, which is actually what I did last fall. So it'll be a really easy redevelopment. Sorry, distraction. I forgot to turn Teams off. I should turn that off so that it doesn't pop up again. Wait, there we go. Where was that? Oh yeah, bridge tables. So notice it fits our third normal form in that bridge table, because there's no horizontal scaling. All we have is primary keys. The primary key for this table, and then foreign keys, which are primary keys elsewhere. So we're not even storing them again. Remember that it shows up twice in the picture, but when it's actually in storage, all we save is a pointer to it. We don't store it again. We just make a little note that says, oh, this value is stored over there. So it doesn't add to our database. And then for the second and third normal form, everything is either a primary attribute, and primary attributes are the new things, right? Like the name of the employee, the salary of the employee. Those are primary attributes about an employee. So everything is either a primary attribute and we don't have any primary, and then an or, and how it's related to the primary key. And we don't have any primary attributes, so we don't even have to worry about that. And same thing for these. Oh, I didn't write that key. Those are all IDs, so they are all foreign keys. Does that make sense? Can I get confirmation on that one? Something in the chat room, one of the little emojis, because that was specifically chosen because that is a situation software developers will hit over and over and over again. So you can see that, and we want to make sure it's normalized, because before we couldn't even type in all of our functionality. In MariaDB, it would not have given us an error message. So it would have been okay to run it, to go ahead and type that code and run it. But in SQL Server and I think Postgre, it wouldn't have let us run the SQL code that I just left off of our thing. MariaDB would have let us run that code, and we would have got an error message later when we tried to update something. So that's the first thing I want to do for as far as editing. So let's get back to our SQL stuff. And clean this up. The fun part, right? The much less confusing part. That's why I wanted to spend so much time on normalization, because it is very confusing. Let me share this with you. Share. Anyone with the link can view, so copy link. I'm sending it out through Ivy Learn for those that watch the video later. That way you can get to the share link and see that picture. Hopefully it makes sense. That's the most important thing we see here, because there are reasons why we want all that functionality that we can't guarantee until we get to third normal form. I'm finally starting to get used to that update, that if you copy and paste a link, it doesn't turn blue until you hit the space bar afterwards. Took a long time to get used to that. It really aggravated me at first, I know that. Okay, so that's the first thing I want to do, is that put in that functionality that we lost, even though I haven't typed it yet, on delete cascade. On delete, on update cascade. So we were completely missing some of our functionality earlier. And then I believe the comma goes down here now instead of up here. So that's the first thing I wanted to do is get in that missing functionality. Even though we haven't actually corrected this stuff yet, we know how to correct it so we can type those lines that we weren't able to do. And do we want to cascade these? So cascade means it'll carry through. If we make a change to the team table, it'll carry through to the employees table with cascade. And change what was already in the employee tables. So an update, we probably want that to happen. But on a delete, maybe somebody showed up for work 8 o'clock in the morning, and around 9:30 they started feeling really sick. So technically they weren't on the team, and then they went home, so they weren't on the team all day, so they weren't working on that job. They went home before the team made it to the job site. So we might need to delete them from that team record. But when we do that, we don't want to go back and delete them from the employees table. Right? Assume they're sick and had a valid reason, they didn't just storm off. Somebody just got mad and stormed off, we might want to delete them from the employees table, but that would be a different situation. So we probably don't want the delete to carry back through. So restrict that from carrying back through. And if we can't, explicit is better than implicit. If we don't explicitly tell the machine what to do, we cannot guarantee what the machine is going to choose to do when that situation arises. It probably won't affect the other day. They'll probably just not bother to do anything with the other tables. And in that case, we have to manually go through and check to see what needs updated and what needs deleted. So very important functionality that we don't want to lose. We can't guarantee until we get to third normal form. Everything past third normal form is optional. So we can do these edits. So skill set. Comes out of there and becomes its own table. We create a table. I'm going to skip the if not exist and just delete it every time because we talked about what if not exist is. And, afterwards, it starts to seem, after we've talked about it, it starts to seem like clutter in the class example. Create a table called skill set. And it's over here in the picture. So we just need those foreign key constraints. So we have a skill set ID, which is an integer. Then we have employee ID, which is again an integer, and an equipment ID, which is an integer. Nope, sorry, scroll too far. Our primary key is going to be that skill set ID. And the constraint, which can be bypassed, we can bypass that, and until you get to advanced situations, there's not a need to do that. But what putting that constraint word in explicitly does is this right here. So this this line right here. Whoops, why'd it go there? Okay, the computer's acting weird. Okay. Nope, still doing it. Why is it only zooming? That's annoying. Oh, I don't know why I was doing it. Nope, I didn't fix it. I thought it was because my pen was still on. Can I write? What that constraint keyword does, I guess zoom's okay, is it gives us a label on here. So I'm gonna call it F. What is going on with this? I'll call that FK underscore employee. Sorry. I don't know why it was acting funny. I think one of my keys was stuck. Keys must have been stuck or something. But we gave that not just all the data fields and the tables, we also gave that relationship between them a name so that we can refer to the relationship without any of the stuff it's actually named. We will not get that far in this class. But hopefully you can see how, especially those of y'all in the software development program, hopefully you can already see what having an explicit reference to everything in our database, how that can be useful. So make one called foreign key employee, which is going to be just like this. I could copy and paste all that stuff. Type it again. It's one line, so splitting it up to make it more readable. And that constraint is going to be a foreign key. And the field that we called employee ID here, which does need to go in parentheses because parentheses indicate it's a field. It's an alternative to saying skill set.employee ID, is we can just put it in parentheses. People have had different programming languages. So if you've had Java or C#, using the parentheses here in our create SQL, that's equivalent to like the this keyword, or for Python, that's kind of like the self keyword. A little bit different, especially when we get to the second half of it. You can think of it that way. And then that references the employee table employee ID field. And everything is in their normal form now, so we don't have any worries about putting on update, cascade, because if an employee learns a new skill, we definitely want that to be shown in our database immediately, right? We're going to want to have them applying that skill out on the job set. On delete, also cascade in this case, because if we fire that employee, we want to make sure that the database doesn't think we have somebody that has that skill set still. Because a customer calls up, is like, yeah, I need a tree cut down. And somebody quickly queries the database, do we have tree service? And it comes back a yes, but maybe we fired that employee last week. So we want to make sure all of our records are up to date all the way across. So if we fire an employee, we want their skill set to be, we want them removed from the skill set so it doesn't look like we have it with our company when we don't. Same thing on the other one. Constraint, so let's put a name on that line in case we need to refer to it. obviously for later classes, that's for later in your study of data analytics. Or for those interested in taking the SQL class in the fall. Whoops, I spoke constraint wrong. Constraint foreign key equipment. Your foreign key, where equipment ID references equipment ID. And equipment can break, so we don't want to, I guess I'll use the same example of a tree. We don't want to say we can do tree service when our chainsaw's broken, right? So we need any changes made to any table to cascade through to every other table where that would be applicable. And really, I could probably copy and paste this over to the other one, the other two bridge tables. So I'm going to copy that, paste. And the other two bridge tables, there was a usage table and an assignments table, which don't seem like they're going to fit on here very well, but and assignments has team ID and employee ID as foreign keys. So we already have employee ID, so we just need the team ID. All of them are integers. This is going to be assignment. Employee is still going to reference employee. And team ID is now going to reference the appropriate one here. So, oh yeah, probably could have ran that first just to make sure that first one worked before copying and pasting it. That would have been a much better idea, but we are under tight. Right, run the first one, and when you have a query that works, then do copy, paste, and edit instead of trying to type it all from scratch again. So this one has a usage ID, and usage involves a team and a piece of equipment. Oh, I didn't explicitly state it. Did y'all see why I did the skill set first before copying and pasting? Put a little bit of thought ahead, and if you know you're going to copy and paste the query, take a second or two to put a little bit of thought ahead and see what the best way, which one of those things is going to be the best copy and paste starting point. Because there's minimal changes here doing skill set first. Because instead of an employee, we need a team ID, which I'll then copy and paste down here. Paste, and change this to team. And that got rid of both of these arrays. And the equipment one, which was written as a mess. Oh wait, equipment didn't have it. Oh yeah, equipment only had one, I guess that wasn't an array. Each piece of equipment only had one skill set with it, but in order to make that other table, it came out of there. So I guess, yeah. So we replaced having the word written with the equipment with just the ID of whatever it was. A text one might be better there. Because we know we're gonna have all unique words, right? Tree, grass, cleanup, and each one of our skill sets is gonna be unique. We're not gonna have very many skill sets for perfect. So we can put the text there, it'll be unique enough instead of an integer. But it needs to come out of this table. Cut it from here. And where was that at? Oh, way up here. And again, a bunch of jumping around. The final result needs to be in a certain order, left to right, top to bottom. But that final result is, that order is probably not how we think about it. So over the years, I found it can be it's far more productive to put it together in the order you think about it in. And if anybody was copying along right with me, I just noticed that I made a typo. I missed some commas. These are all separate things. So if we're doing one thing, so like all of this is a constraint, so we don't need a comma till the end. But we do need commas around there. And that would have been copied and pasted. All right. Hopefully now it's ready to run except for the typos. Any questions on normalizing that table? Our insert queries are different. So I'm going to come down here and comment out the insert queries. Dash dash for a single line comment and slash asterisk for a multi-line comment, and when you get to the end of what you want commented out, asterisk slash, comment them all out. All right. And we'll run the insert query in PHP-MyAdmin. Which, on my computer, I need to go in this way because I'm not sure which one I actually currently have running. I have more than one virtual machine that all have Maria. I think they all have MariaDB and that on there. What? Well, that's inconvenient. Or is that not starting? That was just to restart it, so hopefully it didn't break or anything. I'm pretty sure I have more than one I can use. But it's taking a long time. Oh, it's running. Sorry, let me see if this. Maybe I have more than one local host running. Well, that's annoying, but it's probably a good time for a break, so I will fix that over a break. Or I will reinstall that over a break. So I'm not sure what's going on there. So I'm gonna do this. I go in here to control panel. I was trying to run the one on Jamf. So I'm gonna uninstall Jamf and fix that over the break. I'll reinstall it over the break and then hopefully a new installation will work. The nice thing about virtual machines is just if something goes wrong, delete them and try again. Otherwise, I was planning on taking a break after we uploaded that file. So we're actually only one step away from where I was planning on taking a break anyway. 10 minutes sound good to everybody? My laptop says it is 1:56. So we'll get back to it at 2:06. I'll see y'all in just a moment. Sorry about that. I was planning on running that one, uploading the file and then taking a break, but I have to delete and replace the virtual machine.